Hi everyone, welcome to the classes on engineering mechanics. So myself Adarsh. In today's class we'll be continuing the session what we had discussed. In the last class I have given a brief idea about engineering mechanics and what are the things you should remember or you should bring back from your plus two what you have studied in the physics and like that we have discussed in the last class. So in today's class we will be directly going to our syllabus and we'll be starting our topics. So, whatever things you feel it will be difficult, feel free to ask me during the class or after the class, or you can email me or like that. So, first topic I am going to discuss in today's class is scalar and vector quantities. So, what is a scalar quantity? So, in day-to-day life or in your physics, what you have studied in plus two tenth time, you have gone through many quantities like mass, distance, force, displacement, velocity, like that. Some quantities we need only magnitude. Suppose what is the temperature today? It's 26 degrees Celsius. You know only magnitude. And sometimes we need both magnitude and direction. So what is some? We have applied some force. So how much force? 10 kilonewton force. To know the resultant of the force, we have to know in which direction the force is applied. So simply saying we have applied 10 kilonewton force, we cannot tell the resultant. I have applied 10 kilonewton force on that body. In which direction? Whether upward or downward or towards left, towards right, like that. So some quantities require both direction and magnitude. That are called vector quantities. And some require only magnitude, that are called scalar quantities. So scalar quantities are those quantities which have magnitude only, such as length, mass, time, distance, volume, density, temperature, speed, etc. Vector quantities, those quantities who have both magnitude and direction. Like force, while applying the force we require both magnitude and direction. Displacement. Displacement and distance both are different words. Displacement means I have displaced by 10 meter, or your motor vehicle is displaced by 10 meter. So that is displacing. Displacing, it's moving. So by magnitude alone we cannot define displacements. So we need both magnitude and direction. You have displaced some object to 10 meter in northeast direction or in the south direction or in the west direction, like that. Velocity obeys meter per second. It will have both the magnitude. Again, velocity we record only. We record both magnitude and direction. Acceleration, again we record magnitude and direction. Upward acceleration, downward acceleration, upward velocity, downward velocity, like that. Momentum, etc. So this is a brief idea what is a scalar and a vector quantities. The next thing will be how we represent a vector. Vector will be represented by an arrow. The length of the arrow will be the magnitude of the vector, and the direction of the arrow will show the direction of the quantity. Suppose OA, here you can see a vector represented by OA. Its length is OA, so its length will represent the magnitude, and for convenience we will be writing its value on the vector. And now it is acting from left to right. Okay, so this is how we are representing a vector. It will got both direction and a magnitude. Okay. Second thing, what is a unit vector? Suppose a vector having magnitude unity, that is called a unit vector. We are applying a force. If the value of the force is unity, we will call it as a unit vector. Or we have displaced something. The displacement is a value of my unity. We will be calling it as a unit vector. Similarly, we have equal vectors. If two vectors both having same direction and same magnitude, that we will call it as a equal vector. Vector which are parallel to each other, have same direction and a same magnitude, that is called equal vectors. And second thing is like vector. Like vector is almost similar to equal vector, where same in direction, but their magnitude may not be same. Vectors which are parallel to each other have some sense, but the unequal magnitude, known as like vectors. So this is a base of scalar and vector quantity and how to represent a vector like that. Now we are going to our main topic, composition and resolution of force. Composition, the word meaning combining. Resolution, the word meaning resolving, splitting into 2 or 3 components. That is resolved. Composition, combining, resolution, solving. So in this topic we will be studying about how to combine 2 or 3 forces into a single force, or how to divide one force into 2 force, resolve into 2 force. Okay, what do you mean by composition and resolution of forces? First of all, what are the things a force can do? We just understand what are the things a force can do. The effect of a force. A force may produce the following effects on a body. It may change the motion of the body. Suppose body is at rest or cycle is at rest. You are applying some force, the cycle will start running. So if the body is at rest, the force may set it in motion. And if the body is already in motion, the force may accelerate it. Suppose one boy is cycling and you will be pushing from the backside, it will accelerate its motion. And sometimes we will be applying force to retard the motion of the body. Again, we can take the example of a cycle. If you catch a running cycle from the back, the rider will experience that it will experiencing a retardation. Retardation means the opposite of acceleration. It will feel a braking effect. Also, it may retard the force already acting on the body. That's again the same example. The cycle is running due to the force applied by the rider. When we are applying a retarding force, it will stop the or it will retard the force that is applied by the rider. Okay. And sometimes the force may give rise to internal stresses. Suppose a wooden block is pressed from both sides. Normally, there won't be any physical change we can see if we are pushing. It may be pushed with some help of some machines. It may break like that. If 2 students pushing a big wooden block from both sides, we cannot see any physical effect on that body. But we are applying some force. So it will cause internal stress in the body. So that we will study in the higher semester. Actually, it is the term for mechanical engineers, stress. It is the resistance offered by the body against the applied force. Then we are applying the force on the wooden block, but we cannot see the wooden block is breaking or like that. So that means the wooden block is resisting the applied force. That resistance offered by the wooden block is called the stress. So it's a fourth effect of a force. Sometimes force cannot produce a physical change, so it will produce an internal stress. The second thing, cara of a force. So the force, first thing, it should have a magnitude. Initially thought force is a vector quantity. It should have magnitude and direction. So the force will be acting in the through x-axis, through y-axis, through z-axis, or between x and y, between y and z, like that. It will act in 360-degree angle. Okay, like in a sphere, the force will be starting from the center of the sphere. You can move any direction. So it will have both the direction and the magnitude. The third thing, the nature of the force. We are applying force on an object. It will the effect on the object will depend on the nature of how we are applying. We can take the same example, but you have discussed the previous. A man is cycling, and one person is catching on the back of the cycle. If the second person is trying to pull, then the cycle will experience, it will going to stop. Suppose the person again, it will pushing the cycle will experience an extra force and it will increase the speed. That is the third thing, nature of the force. Whether it's a push or pull, denoted by placing the arrowhead on the line of action of the force. Okay. We will be representing force as a vector quantity. So if we are applying force on the block, we will be representing it as this is a push force, and again this is a block, and I am applying a force here. This is a pull force. Okay. Again, it's a wooden block. The force applied can cause different motion on the wooden block based on the point of application of force. If I am applying the force on here, it will slide the block in this direction. If I am applying the force over here, it will slide the block in the downward direction. Okay. So it will depend on the point at which the force acts. So you have to specify the magnitude, direction, nature of the force, and the point at which the force acts. Okay. Next thing, we are going to study the principle of transmissibility of force. It's a simple principle. We have to study the statement only. While doing the problem, it will automatically come. If a force acts on a body, on a rigid body, it may be also considered to act at any point on the line of action, provided the point is rigid connected with the body. That means this is a body, and I am applying force here of 5 Newton. It will have the same effect if I am applying in the line of action. The line along which the force acts is called a line of action. If I apply the force here or here or here, whatever, condition that the point is rigidly connected to the body. If I am applying here, I can apply here, any point I can apply the force, provided all the points are in line with the force. That is the principle of transmissibility of force. Okay. So again, one more example. I am applying a force here. I can transfer the force to in this position, or I can transfer to in this position. I cannot transfer to this position. So wrong. I cannot transfer to this position. It's also wrong. Or I cannot transfer to this position. It's also wrong. So only possible method is you can transfer along the line of action of the force. That is called the principle of transmissibility of force. And the next thing, we will be studying some kinds of forces. First thing is a coplanar forces. Normally we will having 3 planes, xy plane, yz plane, and xz plane. And actually these 3 are not the plane where we have to consider what all the planes coming in this 360-degree rotation. Suppose xy plane is a horizontal plane and yz plane is a vertical plane. So we have to consider a plane at a 45-degree incline to xy and yz plane. That's also possible. So we can consider n number of planes or infinite number of planes between x, y, z axis. Okay. So our topic is, what is a coplanar forces? If a force, I draw a force here and I draw another force here. I have drawn these 2 forces on the vertical plane. So these 2 forces lies in the same plane. So these 2 forces are called the coplanar forces. Okay. And here is an example. This is a traffic light held by 3 strings. Okay. First, we will go to this point. Actually, from the point, center point, force Q is going in this direction, force P is going in this direction, and force R is going in this direction. All the three forces are in the same plane. So, these three forces are coplanar forces. Okay. Consider the second case. It's a traffic light, and it is held in position by three strings. The strings will experience some force due to the weight of this traffic light. Actually, these three lines are not in a single plane. Actually, this is inclined one. This is again inclined. This is again inclined. So these three forces are not coplanar forces. But line AO and line BO, these two are coplanar, because I can create a plane which containing these two lines. Coplanar force means it should not lie on xy plane or yz plane or zx plane. Condition that two or three forces, three or n number of forces lying on a single plane. If we can accommodate all the forces in a system in a single plane, that are called coplanar forces. So these two forces, or we can take CO and BO. Again, these two, we can create a plane containing these two lines. So again, these two are coplanar forces. Or in other words, any two force can be represented as a coplanar forces. Two force, accommodating two force in a single plane is a silly matter. We can easily do that. But accommodating three forces in a plane, it will be a difficult thing. So we cannot tell that three forces will always be coplanar forces. But two forces will be always coplanar. That's an example. The second thing is a collinear force. Suppose a force is acting here and a force is acting here. These two forces are, this is 5 Newton, this is 7 Newton. Okay. These two forces are lying in the same line. So that means these two forces are collinear. Means, again, one more example. This is a 2 Newton force, and in the same line, this is a 5 Newton force. These two forces again lies in the same line and direction are opposite, but they are called collinear force. Collinear means the forces are on the same line. Okay. The third thing, concurrent force. The force which meet at one point are known as concurrent force. Again, we can take the example of this. The force R, force Q, force P. All these forces will be starting from this point. So we can tell these three forces are concurrent forces. Okay. Again, force AO, force BO, force CO. All these starting from this central point. So we can tell that all the three forces are concurrent forces. Then what are non-concurrent forces? Okay, I am writing here one force in this direction, one force in this direction, and one force in this direction. While considering the three forces, they cannot be concurrent forces. We cannot find a common point of intersection for all the three forces. Okay. Again, one more example. I have force here and I have force here. Whether these two are concurrent forces? Yes, it is concurrent forces, because when I am extending this force, it will meet at point. So it will be originating from single point. I have one more example. Here is one force, here is another force. Whether these two are concurrent forces? No, there are. Even I extend that to both, then it will not intersect. These two are parallel forces. So two parallel forces cannot be a concurrent force. Okay. But two non-parallel force always be a concurrent force. So that is the concept of concurrent force. So we have discussed the coplanar forces, collinear forces, and the concurrent force. Okay. The next thing we are discussing in connection with the three things we have always is coplanar and the concurrent forces. So this is the example. All the three forces are in the same plane and all the three forces are originating at the same point. It's called coplanar and the concurrent forces. Second thing, coplanar and the non-concurrent forces. So this is the thing which I drawn here, the above example. Okay, one minute. The thing, this is the example of coplanar. All the three forces are on the same plane I have drawn here, but they are not have a common intersecting point. That is the coplanar non-concurrent force. Third one, non-coplanar concurrent force. Here is example, this traffic light. All the three forces cannot be incorporated in a single plane. So it's not coplanar, but they are concurrent. Okay. The fourth one, non-coplanar, non-concurrent. If this not having a common point of intersection, we can call it as a non-coplanar. Now, already it is a coplanar forces. If it is don't have any non-common point of intersection, we can call it as a non-coplanar, non-concurrent force. Okay. So next thing we are going to discuss the resultant and the composition of a force. In the starting itself, I have mentioned what is the resultant. If a number of forces, PQR, we have three forces, and if we are representing it as a single force, then it is called the resultant force. If we have a number of forces, PQR, etc., acting simultaneously on a particle, then it is possible to find the single force which can replace them, and which have the same effect produced by all the three given force. We can replace any force, but we have to replace the force which have the same effect produced by, suppose we have three forces and it will produce some tilting or rolling effect on the body, and the resultant force should produce the same effect, tilting or rolling effect on the same body in the same intensity as the produced by the three forces. Then it is called the resultant of the force. Normally we are representing the resultant with the letter capital R. Okay. Second thing, composition of force. The process of finding out the resultant, it is called composition. Okay. And for finding out the method, we will be using analytical method and a method of resolution. In analytical method, we will be discussing parallelogram law and the method of resolution. So we will be discussing the parallelogram law first. So we can take down the note, analytical method and the method of resolution. And the analytical method, we had two classifications, parallelogram law of force and the method of resolution. In parallelogram law, you can see in this figure the force P. Here you can force P. Here is actually force Q. Okay. These two forces. To find the resultant of these two forces, we are representing these two forces as the two sides of the parallelogram. We are representing P here, again P here, and a Q here, and a Q here. Then the diagonal will give the resultant of the vector. Okay. Actually, there is a proof for this. Okay, actually, normally, now it's not asking for the examination. That's why I skipped. Anyway, if I get time, I will discuss in detail. So just study the equation. If the law states that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of the parallelogram, two adjacent sides, P and Q, not opposite side, two adjacent sides of the parallelogram, then the resultant may be represented by the magnitude and direction by the diagonal of the parallelogram. So the diagonal will give the resultant of the picture. Okay. So for the actually here instead of P and Q, here it is written as F1 and F2. So we can write the resultant as F1 square plus F2 square 2 F1 F2 cos theta. We have to study this equation. Resultant is equal to f1 square plus f2 square plus 2f1 f2 cos theta. So theta is the angle between P and Q. This is the angle. So theta is the angle between P and Q. If theta becomes 0, P will be in this direction and Q will be in the same direction. Okay, so this cos theta will become cos 0 equal to 1, cos theta will become 1. So f1 square plus f2 square plus 2f1 f2, or we can write resultant is equal to a plus b all square, or we can write resultant equal to p plus q if theta is equal to 0 degree. Okay, and if theta is equal to 90 degree, this cos 0 becomes 0, root of f1 square plus f2 square, or p square plus q square will give the angle. And the second formula we have to study the angle alpha. Alpha is the angle of the resultant. This is the angle alpha. Here it is written angle alpha. This is the angle of the resultant, which is given by f2 sin alpha divided by f1 plus f2 cos theta. f2 sin theta divided by f1 plus f2 cos theta. So again, these two equations you have to study and by heart by writing 2 or 10 or 20 times in your notebook. Whether actually this equation is easy to understand. f1 square plus f2 f1 of cos theta. This one tan alpha is a little bit confusing, sin theta and cos theta like that. So if you have any confusion, just write 20 or 10 times. That will help you to understand this equation. Okay. So f1 f2 are the forces. Here in this figure it is known as P and Q. Theta is the angle between force. Alpha is the angle of the resultant, and alpha is given. One more thing. Actually, alpha is the angle made with P or f1. Suppose we need this angle. What is the angle made with f2? So again, either we can subtract from theta, or we can use another equation. Instead of f1, f2 will be writing f1. All f2 will be replaced by f1. All f1 will be replaced by f2. Will give the angle made with the certain force f2. Initially it is made with f1. Now it is made with the f2. This is the parallelogram law of forces, and we will be discussing some problems in connection with this in the coming classes. Okay, thank you.